Thank you so much for the reactions for my last video illustrating permutation of objects in my YouTube channel. Most especially to Mylene Pahalia and Natalie Florita. Thank you so much for your comment. Thank you also to Jerly Durano. Thank you for your comment.
Hello there, class. Welcome to the second module for the third quarter. Our lesson is about solving problems involving permutations. This is for grade 10 mathematics and from version 5. I am your teacher, Mr. Anthony G. Arisgado, teacher 3 of Bukidnon National High School. Are you ready for the class? Let's go! The objectives for today's lesson. At the end of this session, the learner would be able to solve problems in permutations, including distinguishable and circular permutations. Lesson 1. Solving problems in permutations using the FCP or the Fundamental Counting Principle. Let us have a short review about it. The fundamental counting principle or the fundamental principle of counting is a counting technique in which if two events are independent and one event occurs in A ways and the other event occurs in B ways, then these events occur in A times B ways. Let's see how FCP works. Example 1. In how many ways can four-letter word code or CODE be arranged its letters 3 at a time? Example, C, O, and D. That's one arrangement. So, let's take a look at the word code. There are 4 letters. And if we're going to pick our first letter, it will be from 4 letters. Yes, we have 4 choices for the first pick. After having our first pick, then how many letters are left? Okay, 3. Okay, so there will be 3 letters to choose from for the second pick. After picking the second letter, then our choices will go down to 2 letters. Okay, so these are the numbers that we are using. And by FCP, the solution would be 4 times 3 times 2, which is equal to 24. So, there are 24 ways to arrange the letters of the word code if taken 3 at a time. I hope you understand that. If you are still having a little confusion, then let's have example number 2. 12 students compete in a race. In how many ways will the first 3 prizes be given? So the first 3 prizes would be the first place, second place, and then the third place. Okay? Or the gold, silver, and bronze prizes. So take note that in the problem, we have our number of objects as 12. Now, there are 12 students. When one among the 12 wins, how many students are we choosing second from? Okay, so 11. And after choosing the second place, or after the second student win the second place, then there will be 10 students left. So these are the numbers that we are going to make use for our FCP, and the solution will be 12 times 11 times 10, which is equal to 1,320. Therefore, there are 1,320 ways that the first 3 prizes would be given. Let's go to lesson 2. Solving problems using permutation formula. Computing the number of permutations will be given by the P of N and R, or the permutations of the N number of objects taken R at a time, which is equal to N factorial divided by the quantity of n minus r factorial, where n must be greater than or equal to r, where n is the total number of objects and r is the number of permutations to be formed. Okay, let's apply this formula now. Using the permutation formula, we have example 1. In how many ways can a 4-letter word code be arranged its letters 3 at a time? Take note that this is the same example for FCP. Now, let us see the difference. We have our number of objects 4, and the permutation stated by the problem is to take 3 letters at a time. Okay? So, let's substitute this given to our equation, which will be the permutation of 4 objects taken 3 at a time is equal to 4 factorial, which is the n, and then the quantity of 4 minus 3 for n minus r, then factorial. Solving, we have 4 factorial is 4 times 3 times 2 times 1. And 4 minus 3 is equal to 1. And, okay, simplifying, 4 times 3 times 2 times 1 is 24. Divided by 1, because 1 factorial is 1, the answer is 24. Therefore, there are 24 ways to arrange the letters of the word code if taken 3 at a time. The same answer using FCP, right? Example number 2. 12 students compete in a race. In how many ways will the first 3 prizes be given? The given are the following. We have 12 objects for 12 students, and the number of permutations prescribed in the problem is 3. So we have the given n equals 12 and r equals 3. Okay, so using the given, we have the permutations of 12 objects taken 3 at a time is equal to 12 factorial divided by the quantity of 12 minus 3 factorial. Solving, we have there 12 times 11 times 10 times 9 factorial. I wrote until 9 factorial only because 12 minus 3 is equal to 9. And our divisor is 9 factorial. So we can just divide 9 factorial divided by 9 factorial. It will be, 1. So what's left are the numbers 12 times 11 times 10 divided by 1. And the answer is 1,320. And there are 1,320 ways that the first 3 prizes would be given. You got that one? Very good! Thank you so much. Okay, let's proceed now. Lesson 3. Solving problems using distinguishable permutation. What is this? Let us have a simple recall. A permutation of non-distinct objects refers to the different arrangements when one or more objects are identical or the same. This is one of the lessons we had in our Module 1 for the 3rd quarter. Okay, example, arranging the letters of the word tree, which is T-R-E-E. And we have 2 E's, right? Let's do the example. Example 1. How many distinguishable permutations exist for the letters in the word Tennessee? Okay, this is a state in America, in USA. Okay, so by looking at the word Tennessee, then we have T-E-N-N-E-S-S-E-E. So we have 9 letters for the word. And we have letters that are repeated. We have 1 T, we have 4 E's, and then 2 N's, and then 2 S. Okay, the number of objects, 9. So we can solve this one. In solving distinguishable permutation, it will be like this. The permutation of the total number of objects is 9. So we have there 9 factorial. We have a 4-letter E, so we have 4 factorial. we have 2 letter n, so we have 2 factorial and another 2 factorial for 2 letter s. Okay? Then, simplify 9 factorial, which is 9 times 8 times 7 times 6 times 5, just until 4 factorial because we have 4 factorials in the divisor. So, we can divide 4 factorials divided by 4 factorials just like that. And then 2 factorial is 2 times 1 and another 2 factorial is 2 times 1. And also with the number 2 in the divisor, we can divide it from 8. So 8 divided by 2, okay, what's left would be 4 for the first 2, and then the second divisor 2, then 2 is left. It will be like this. The permutation of 9 instead of 8 will become now 2. Then copy 7 times 6 times 5. And there are 3,780 arrangements. Statement for the answer: there are 3,780 distinguishable permutations for the letters in the word Tennessee. Okay? So let's have now a circular permutation. It's the next lesson. How many possible arrangements are there for 3 people to be seated around a circular table? So we have this example before. So we have here the first arrangement: A on top, B on the left, and C on the right. Second arrangement: B on top, A on the right, C on the left. And next arrangement: C on top, B on the right, A on the left. Another arrangement: A on top, B on the right, C on the left. Another arrangement: C on top, A on the right, B on the left. And another arrangement: B on top, C on the right, and A on the left. And take note that for the first line, we have there, okay, the arrangement of our first figure is just rotated clockwise. The first figure for the second line is just rotated also clockwise. So, there are only 2 possible arrangements if 3 people are seated around a circular table. But the solution, it will be like this. The permutation is equal to the quantity of n minus 1 factorial, where n is the total number of objects. In this case, we have 3. So, substitute 3 to n. So, we have there 3p equals 2 factorial, and 2 factorial is just 2 times 1, which is equal to 2. Therefore, there are 2 possible arrangements if 3 people are seated around a circular table. I hope you got this. Solve the following. So we have here exercises. How many possible arrangements are there if 11 campers will be seated around the campfire? And the second, how many possible arrangements will be for the letters in the word tendered? Let's solve. Number 1. How many possible arrangements are there if 11 campers will be seated around the campfire? So using the circular permutation, we have 11 objects to consider, and our formula is P equals the quantity of n minus 1 factorial, where n is 11, so 11 minus 1. Then 11 minus 1 is 10. 10 factorial is equal to 3,628,800. The answer for number 1, there are 3,628,800 possible arrangements. Okay? Number 2. How many possible arrangements will there be for the letters of the word tendered? So, taking a look at the word, we have T-E-N-D-R-E-R-E-D. Okay, 2, 4, 6, 8. There are 8 objects. And we have E repeated 3 times and D repeated 2 times. So let's solve using the number of objects 8. So we have the permutation of 8 factorial because our n is 8, and then the repeated letters E is 3, so 3 factorial. D is repeated 2 times, so 2 factorials. For the 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 factorial. Because we have there in the divisor 3 factorial. So we can just divide 3 factorial, divide by 3 factorial, that's 1. Also, we can divide 4 by 2. So, 2 will be left on top or in the dividend. So, simplifying, we have 8 times 7 times 6 times 5 times 2, which is equal to 3,360. Therefore, there are 3,360 distinguishable permutations for the letters in the word tendered. I hope you got that one. Okay, if you have questions, you may post it in the comment section. Thank you so much. And for your exercises at home, you can answer this assignment and submit this to your grade 10 mathematics teacher. Are you ready? Our assignment is this. So you can just screenshot this one and solve. For my students, just answer one distinguishable permutation and one circular permutation from this assignment. Thank you so much. Okay, class, that ends our lesson. Thank you so much for watching. I am Mr. Anthony G. Arisgado, Teacher 3 of Bukidnon National High School, a teacher in Icon Live for Mathematics 10. Thank you so much. Mathematics is for everyone and math is fun. Bye-bye. God bless you.